I don't need to introduce our next speaker. You guys know him here at Angers. It's Mr. Green IT Warrior. Nicolas Gutowski from ESAIP Group in Angers on Green IT and Relational Database Management Systems. Nicolas, yes, over to you.
I will be with Iman El Alawi, with PHP students in the laboratory LARIS, in collaboration with University of Angers and University of Kenitra. So she will introduce the conference.
Okay, Iman, hi, nice to have you here. Let me give you your microphone.
Yes, just before the introduction, I just want to start with something. I want to break popular belief that data are clean and data are not consuming some energy. So just was wondering on Sunday was when I make my footing, how I can explain that, how I can break this popular belief. So just you think that when you run on when you do bicycles, it's free of energy maybe, or free of carbon dioxide emissions, but it's not true. Of course, a runner like me, for example, use some energy for performing 10 kilometers. For example, 10 kilometers running is roughly 700 kilocalories, and equivalent to 814 watt-hours. So it's very, very amazing. So it's equivalent to roughly 54 energy saving light bulbs switched on for almost 1 hour. So running is responsible for two carbon dioxide equivalent emission. And if I compare me with a server on a database, my brain makes some data storage, data processing, and it consumes some energy. Also my muscle, of course, on the server. So both of them, me and the server, are using energy, and it's responsible to carbon dioxide equivalent emissions. So after this short presentation, I just let Iman to introduce the skills on big data, because we need some information to understand why I'm here to present the green data with RDBMS and why we need some green data.
Hi everyone. My name is El Alawi Iman. I'm a PhD student, and the topic of my PhD is to suggest a method for big data analysis. So we're going to start with a definition with big data. Nowadays, everybody uses internet to check mails, to send one, publish status on Facebook, like photos, do research on internet, or even go shopping online. So, in short, we can't live without internet. Is there anyone who can live without internet? See, no one. But as you probably know, all of our action on internet generate digital tracks, causing the explosion of storage servers dimensions. So the most critical problem here is how to extract value from big data, knowing that it can't be perceived, acquired, managed, and processed by traditional IT and software or hardware sold within a tolerable time. Big data is also described within the Gartner definition based on the 3 V's. The first V is volume, size of data, means with the generation and the collection of masses of data, the data scale becomes increasingly big. And I will get back to it in the next slide and give you some numbers to show you how big it is. The second V is velocity, how fast data is being generated, and I will talk about it in the next slide too. So the third V is variety, indicates the various types of data, which include semi-structured and unstructured data, such as videos, audios, or text, as well as traditional structured data. Allow me to give you an example to show you the potential of big data. Is there anyone who knows how Germany won the World Cup? Okay. So they used big data. How? According to the assistant coach of Germany, a team of about 50 students at Cologne Sports University developed a huge database over the last 2 years, and matching up data from different sources about the teams playing in the World Cup. So the German team was able to catch and analyze every moment about the Brazilian team. So they were able to notice their weakness and strategy. So they were able to tackle the weakness, the time's weakness. So how much data is generated every minute? Minutes, 16 seconds. It's a very short moment, which sometimes goes unnoticeable, but not for the internet. In 1 minute, Google receives over than 4 million search queries, and Facebook users share over than 2 million pieces of content. And YouTube users upload 72 hours of new video. For information, it takes over than 11 years to see the uploaded video in 1 day. And Apple users download 48,000 applications in minutes. As you can see, internet is used exhaustively. And you can imagine the amount of electrical energy needed to run server internet in 1 minute. So allow me to give you some numbers to show you better the energetic impact of big data. So according to Dalkia, a data center of 10,000 square meters consume as much energy as a city of 50,000 inhabitants. And the few 500,000 data centers in the world consume about 3 billion watts per year. It's almost the production of 30 nuclear centers, according to a study carried out by Stanford University. And in France, the data center consume 9% of country's electricity according to France culture. So we have to find a solution to reduce the energetic impact of big data. So we can maximize the performance of computing resources by developing methods for minimizing energy consumption, and it's in 2 ways. We can maximize minimize energy consumption by maximizing the performance of computer resources. And here, even a small optimization can offer energy and cost savings. And now I will let Nicolas tell you more about Green IT. Thank you.
Thank you for setting up the purpose. Thank you. So now this consideration drives us to different experiments on measurements. So firstly, my first objectives of research was to measure the global power consumption and the response time of Oracle transactional millions insertions. So I just tried to simulate 5 million insertions in a 3 column tables on a single server, and just to monitor, to measure the power consumption of this query. On second objectives, I was wondering where I can just localize energy consumption. And I focus the measurements on the processor power consumption in order to figure out if the processing is due to the processor. And thirdly, I know that students from Europe and France now are working on green patterns. So I'm working to optimize the algorithm involved in these 5 million insertions and measure the difference of the optimization. So the procedure was firstly to simulate 5 million insertions in a 3 column table on a single server using a for loop, traditional for loop. And secondly, try to simulate 5 million sessions in a 3-columns table with a more optimized method of PLC qual programming, which is with a for-all method. You will see that later. So what answer I am trying to get? I'm trying to answer to how dirty are your data, firstly. What could we optimize? What could we improve? Where is the energy consumption localized? Maybe in the processor, we will see. So what I use as an architecture was a single server, a really easy, simple server. I also work with a client server architecture, but I won't have the time to present this, unfortunately. So I use this architecture with 2 tables. The first table was test4 with the 3 columns, and the same table then test4 was test for all. In the first table, I tried to insert 5 million data with the for loop method. And in the second table, with the test for all table, I just try to insert 5 million data with the for all algorithm. And of course, I measure in both cases the global power consumptions and also the processor power consumptions. So I use for that one power meter, a Worldcraft Energy Logger 4000F with SD card recorder. I use my personal server, which is a little server with an Intel Core i5 CPU, using also 4 GB RAM, virtualizing Windows Server 2003 with Oracle 11G. This processor was with a TDP of 45 watts. The TDP is the thermal design power, really useful for this application. And after, maybe you watch, I hope you watch the conference of INRIA, who presents the Power API measurements and how it works. It's a really, really useful application to monitor, to measure the different consumptions of the processor. So I use this, this software. Firstly, I just measure the nominal consumption of the server. So it's, you can see here the actual power needed by the server with no queries, with nothing. It's roughly 9 watt in 10 minutes. After that, I use the for loop method to insert 5 million lines. So you can see in 3 minutes and 54 seconds, we have a little peak of power with a max power of 79 and 96 watts. It's roughly 7 watt-hour consumption. So you can see the difference, you can watch the difference between a nominal functionment and when I insert the 5 million lines. So data, I can prove here that data are not clean. They are not really clean and they need some energy. But where is the main consumption localized? I guessed it was in the processor, and I proved them. I proved it, sorry. You can see here that with Power API, I monitor the Oracle processes PID. So I listen this PID. And you can see that we have a lot of, we need a lot of energy, and we reach very oftenly the max power, which is 32 watts. So it needs a lot of energy to process the insertion, to store the data. So what can I conclude for this first experiment? I can conclude that the processor is the main component responsible to the energy consumption variation during Oracle queries insertions. So if you want to act, if you want to work in green patterns, dear students, with a database and their developers also, you can act more in the processor way, so with the data process. That's why it's really important for the big data. What are the perspectives with this first consideration? Firstly, we can improve the algorithm of insertions, of course. We need that. Secondly, maybe we can work on optimizing the different caches, like data caches or log cache. And thirdly, we can measure the epsilon. So epsilon here is the remaining energy consumption that we won't have measure for the moment. We don't have localized it. So now I use the second method. I speak about improving the algorithm of insertion. So I work with the second algorithm, which is the for-all method. And as you can see, it's really amazing. We have a relevant results because instead of having 4 minutes of insertions, I decreased to 8 seconds roughly in insertions for 5 minutes for the same insertions. So really amazing. It's very good for performance, but it's also eco-friendly. It's more eco-friendly. It makes sense when you see the results. It's 0.15 watt-hour. So really amazing for that. So just by using a for-all method for inserting 5 million data instead of using for-loop method, I decrease the response time from 4 minutes to 8 seconds, and I decrease also the energy consumption from 7 watt-hour to 0.15 watt-hour. But where is also localized this consumption? It's localized also in the processor, as you can see here, but we reach less oftenly the max power. So the processor is more free for working in other tasks. So it's really optimized. Same conclusion, the processor is the main component responsible to the energy consumption variation during Oracle queries insertion by the for-all method. So it's the same things. But what else? What I can do now? Firstly, I can compare global consumption between both methods, for loop and for all. I can compare the processor consumption between both methods, for loop and for all. So here is the synthesis. If I just take a look for my first experiment with the for loop method, I can just say now that it's equivalent to an energy saving light bulb switched on for almost 30 minutes, only for 5 million data. And as you know, there is a lot of data inserting in a day. And if I compare with the for all methods, it's only equivalent to an energy saving light bulb switched on less than 1 minute. So you can just consider that these results are really relevant. Green patterns and dirty patterns. This is the proof of concept of what I want you to understand with this easy example. How it works. This is the last slides, more just 3 slides lasting. How it works. If I explain the for loop, when we execute the for loop script block, the PL SQL engine will switch over the SQL engine, and it will switch over to the SQL engine 5 million times, regarding to our experiments, of course. Once for each row being inserted. That's why it's a lot of response time, it's a lot of energy consumption. But when I decide to use the for all method, it's not the same thing. For all is not a loop. For loop is a statement. It is a declarative statement to the PL SQL engine. And it generates all the DML statements that will have been executed one row at a time and send them all across to the SQL engine with one context switch. So just one switch instead of 5 million. That's why here you can watch the difference of energy consumption. Now it can conduce to other research and perspectives, of course. We can separate the period of the DML statement creation on the real data insertion. We can also work with a client-server architecture. I already did it. We can optimize different cache. Because we can work with NoSQL. Why not? Because all big data today are mainly NoSQL. We can use the energy footprint as an indicator of Green IT good practices. Thank you for your attention. And now you can ask questions. If you have any question, I will be pleased to answer to it.
Thanks. Thank you. we've got a few questions prepared, and then I'm sure there are some questions from the room. You started by illustrating a fact, and the fact is that performance, so response time and savings, go hand in hand.
In this case, yes, but it's not really. It's not often the same case, because you can have a lot of performance needed, and that it requires more energy. In my case, I optimize, I improve the performance, and I have an energy gain. It's only in my case.
Okay, and what is the position of developers? Do developers commonly accept this fact?
In the world of database administration, they accept that because Green IT is binding to performance, is binding to Oracle tuning. So we need to get some database which are really optimized to manage data, to process data, to store data, and we have to struggle with this kind of problem, of issue.
Okay, Oracle, a huge player, a huge publisher. Imen showed some examples earlier of data transfer with tools that we all know on Web 2, social media. What about the position of huge publishers, software publishers such as Oracle, a major player? What is their position with regard to green IT and green patterns?
For the moment, they don't really use the term green IT. They understand green IT by using the way of performance, by using the way of tuning databases. We will ask the question to Willy Lambert after that, because it's the same thing for Luc Durand, Enterprise, here in Angers, because they use the green IT for optimization. They need that. If you remember well, in the 90s, in the 20th century, so in the 90s, we don't have the choice. We use green IT because we don't have enough memory, we don't have enough processors, so we already use green IT. And now we just use these terms because we know that, okay, we have a lot of memory, we have a lot of processor, we can develop, we can program as we want. But we can't continue like that because of the energy footprint, because of the carbon footprint of the IT. And now we use the term of green IT to use what we already did as a good practices, as a programming good practices.
Okay, and a question about good practices. Do good practices change from one publishing company to another, or is there a generalization?
I think there are different good practices, but also we can have general practices, because databases, if I speak about SQL Server, if I speak about Oracle, it's roughly the same things of, in instance, work with the memory, work with the processor, there is data cache, there is log cache, and we can optimize the same thing, I think, with both of them and with the different database solutions.
Okay, thanks. Questions out in the audience? I was going to say it's not possible that there are no questions. There is a question.
You can also have questions to Iman if you want with the big data.
Okay, my question is, you use a huge amount of queries in your demonstration, but if we have 5 or 10 queries to insert, is it also the for all method better than the for loop? Or?
No, I test it, yes. If I have just 5 insertions, the for method is not really good in energy consumption, is not also really good for response time. It's better to use for loop. It's only for big data. It's only for a huge data insertions.
And do you know the gap, the number of queries?
Yes, I try it also. After 10,000, you can have relevant results.
Thank you.
You're welcome.
No questions? Obviously the message is clear.
Yes, maybe.
your students don't want to test you, obviously. Okay, last chance.
Don't be afraid. You can try it if you want.
Oh, they are afraid.
Yes, maybe. One question, one good mark.
Oh, that's a good idea, and the same for me.
I'm kidding, of course.
Okay.
Thank you.
Thank you. Thank you, Nicolas. Thank you, Imen, as well.